Alright, y'all, today we're going to begin our talk about conics, okay? And some of the conics that we're going to be talking about in this particular unit will be parabolas and ellipses and hyperbolas. Today we're going to focus our attention on parabolas. Now, we have the formal definition for a parabola, and I'll just read what it states. We're not going to write it, but this is just for information. A parabola is the set of all points, x, y, in a plane that are equidistant from a fixed line, called the directrix, and a fixed point, called the focus, not on the line. Now, that's the formal definition, but, you know, reading all that really doesn't tell us anything about what parabola is. Let's go into looking at the standard equation for a parabola. Okay? And we're going to have four situations, and we're going to draw those situations out. But the standard form of the equation of a parabola with vertex at the point HK is x minus h squared equals 4p y minus k, and this is p cannot be 0. In this situation we have a vertical axis, and the directrix is the line y equals k minus p. Because we can have a parabola, what, turn up or down, okay? And that's this case, okay? And then we can have a parabola turn right or left, and that's this case. This means we have a horizontal axis, and our directrix in this case is the line x equals h minus p. Okay? The focus lies on the axis p units from the vertex, okay? The focus lies on the axis p units from the vertex. And we're going to talk about the focus in a minute. But notice, my x portion is squared here. It's a line, and we're going to draw these situations and it'll become more clear. Okay? But notice here the x is squared. So we have a parabola that's pointing upward or downward. When the y portion is squared, it's either going to be pointing left or right. Okay? Now, if the vertex is the point 0, 0, then we know that these equations can simplify down some. So if the vertex is the point 0, 0, then this first equation turns into x squared equals 4py, and the second equation turns into y squared equals 4px. So it simplifies down some when our vertex is the point 0, 0. Now let's talk about what this vertical axis and horizontal axis and directrix and all this stuff and the focus means. Okay? So we're going to first of all look at vertical axis. Suppose the axis is vertical. I may have a parabola pointing upward like that. Okay? The axis is the line x equals h, where h is what? The first coordinate of that vertex. Okay? And I guess I should draw dotted lines here, because it's not to say that this will be the x and y axis. So we'll just draw vertical lines, or we'll draw dotted lines, okay? Because this could be any line, okay? Doesn't have to be the x and y axis, just any line, okay? X equals h is the axis in this case. This point here is our HK, which is our vertex. This line here that's dotted is called our directrix, and that's the line y equals k minus p when we're in this horizontal case. Okay, so it probably won't be the x axis, but that's the directrix. And if we have our focus here, then the distance from the vertex to the focus is that P. And the focus here is the point H, comma, K plus P. That's the focus. Now, as we said, that the directrix, a parabola is a set of all points equal distance from the directrix and a fixed point on the focus. So the distance from here to here is also P. Okay? It's also P. This vertex is in the middle of this directrix and that focus. But that's just a reference line for us. Now this is for a vertical axis. We could also have the case where this thing is pointing downward. Okay? This is still the vertex. This could be, well, that's not the focus. This needs to be the focus closer to that because of the way I drew that directrix. This is the focus. This is a directrix. Now, the focus, all of these formulas that we used up here apply here also. All in this vertical state. But this is the point, or the equation, x equals h squared equals 4p times y minus k. And this p, we should say, is a directed distance. And what that means is that if we're looking from here to here, P is positive. Okay? In this situation, P will be positive. And if I look from here to here, this is also P, but I'm going down. So in this situation, P is what? Negative. If you remember just by dealing with algebra, if that constant, in front of that squared term was positive, it pointed up, or negative, it pointed down. So we look at P. Going from here to there, we're going up, positive. From here to there, it's negative. But this is still the same equation. But P will be positive in this situation, negative in this situation, and all of these hold true. Both of those are the vertical case, vertical axis. Now let's look at the horizontal case. Okay? The horizontal case where we will have parabolas turn sideways. Okay? So, okay? Suppose we have a sideways parabola like this, okay? This vertical line here is our directrix. And now it is x equals h minus p. This horizontal line is our axis. Okay? And in this case, the axis is y equals k. Okay? This is still our vertex, the point HK. And now we have our focus, and that is the point H plus P, comma K. And this distance here again is our P. Okay? Still P from the vertex to the focus. So my directrix here, P is going to be what? Greater than 0 because I'm going here going toward positive numbers. Okay? I can also have the situation where I'm turned the other way. Okay? This I'm turning toward the right, but again, this vertical line is my directrix with the same equation there. This is still my axis, same equation for the axis. This is my vertex, my focus. Okay, still the same things here. This distance is my P, but now P will be what? Negative. And my form for this is y minus k squared equals 4p times x minus h. Okay?
That's your formula for both of those?
Uh-huh.
Even though they're swapped on, even though P is negative on one?
It just, whatever P is, it could be negative or positive. That's still the formula. Now, that's very important because that's going to help us sketch some graphs and get some standard forms of some parabolas. So we'll probably leave all of that up on the board today, okay? Because we will be referring back to these pictures here. So the next few examples, we want to find the vertex, focus, directrix, and with these we also want to sketch. And really to sketch, we really need the vertex pretty much. And we can draw the focus and we can draw the directrix, but after we find P, we'll know whether it's up or down, to the right or to the left. So the first example that we're going to do, we're given y squared equals 3x. Okay, y squared equals 3x. Now, when we're dealing with that, we should be able to pick out our vertex. What is the vertex? We know that this y is squared here, so we're dealing in this horizontal case, right? So it's y minus k, where there is no k, and x minus h, there is no h. So hk is 0, 0. It's of this form here. When the vertex is 0, 0, we're of that form, okay? So our vertex is at the origin, okay? Now, if we're at the origin, the general form is y squared equals 4px, right? Right? And if I compare this, I can get that 4p will equal what from the form equation? 3. Okay? Which means p will be what? 3/4. Okay? P is 3/4. And this is greater than 0, so I'm in the first situation. P is greater than 0. I knew I had a horizontal axis. Okay, I knew I had a horizontal axis because what was squared? Y. Okay? So I'm in one of these situations. Then I need to figure out what P is. And P is positive, so I'm in this situation where it's turning to the what? To the right. Okay? So I know what P is. I can now find my focus. The focus over here we said was the point H plus P, comma K. Well, this is HK, right? So H plus P is 3/4. So that's the point 3/4, 0. And my directrix in this situation is the point X equals H minus P. So X is negative 3/4. So what does all this mean for this particular problem? Okay, I have found my vertex, focus, and directrix. Now I need to sketch. Well, X equals negative 3/4. If I call this negative 1, then negative 3/4 is about here. That's my directrix. My vertex is here, and my focus is the point. I call that 1. It's 3/4 0, and I'm pointing this way. Okay? Okay, because this is the equation that was given, y squared equals 3x. Well, when my center is, my vertex is 0, 0, then by over there, I have y squared equals 4px. These are the exact same, but I need 4p will equal 3, just by equating those two equations together. Okay? Let's look at another one. X plus 1/2 squared equals 4y minus 1. So my x is squared, so I have a what? Vertical axis, right? So, and I know that here my vertex is the point, well, this should be x what? Minus h plus, right, x minus h squared equals 4py minus k. So it's negative 1/2 1. You got to get these negatives right. Right, the standard form, x minus h squared equals what? 4py minus k. I need that negative, so that becomes negative 1/2. My negative is already here, so I get that 1. That's my vertex. H comma K. Now, here I have this 4 portion and this 4p portion. So 4p equals what? 4. Which means p equals 1. Right? And this is greater than 0. So I'm in a situation where I have a vertical axis and my parabola is pointing upward. So I'm in what? This first situation here. Okay? Now, I'm in that first situation. What is my directrix? The directrix over there, we have what? Y equals K minus P, which is what? K is 1, P is 1. So my directrix is the line Y equals 0, which is the what? Horizontal line. Horizontal axis. And my focus for that situation is the point H, comma, K plus P. My H is -1/2. My K plus P is what? 2. Okay? So I have my focus, my directrix, and my vertex. Now I need to sketch.
Why is it we made the 1/2 negative?
Because the form is x minus h, and the only way I can get x minus h is to do x minus a negative. So it becomes -1/2. Right? He said, why is the 1/2 negative with the vertex? The form is x minus h. So how do I get a minus here? By putting a double negative. So h will be -1/2.
Regardless of what the problem is, you just change it to what the form would be.
I don't really know how to answer that, because you're really not changing to what the, well, you're getting in that form, but it's still the same. See, this thing, they're the same equations, are they not? But when this is negative, we just take the what? The h portion, which is -1/2, and the 1.
So if it had been x minus 1/2.
Then it would have been +1/2. So what's my graph? My x-axis is my directrix. Okay. My what? Focus, or my vertex is the point -1/2. I call this 1 and 1. -1/2, 1. And my focus is the point -1/2, 2. So I'm doing what? I'm pointing upward. It's my focus, my vertex, and my directrix. And I knew it was pointing up because what? Because P was greater than 0. Right? P was greater than 0. I knew it was a vertical axis because my X was squared. Okay? Look at another one. X equals 1/4 times y squared plus 2y plus 33. Now this is different. And we're going to have to make this look like that. Okay? But which variable is being squared here? Y. Which means we're dealing with the what? Horizontal axis. So we know we need the y portion squared. So what I want to do is, first of all, I'm going to get rid of that 1/4. I can easily do that by multiplying everything by what? 4. So I have 4x equals y squared plus 2y plus 33. Multiply this by 4 and that by 4. And that's going to be easier for me to think about. And I'm going to have to do, I'm going to end up having to do something that you may not have done for a long time, but that's going to be completing the square. Now remember about completing the square. So what I need to do is to get my what? Y terms over here by themselves, which means I need to get that what? 33 to the other side. Right? So I take half of 2, which is what? 1, and I square 1. and I add that number here and that number there. This produces a perfect square, y plus 1 squared. Y'all remember that? Completing the square? Here, you look at your y term. And depending upon what that coefficient is, if this coefficient is not 1, you're going to have to factor it out to make it 1. Then you look at this term with just the y to the first power. You look at 2. I take half of 2, take half of whatever that constant is, which is what? 1. And then I square it. 1 squared is 1. And that's what I add here and there. This becomes a perfect square. This number will be whatever half of that number is. Okay? And this becomes 4x minus 32. And it's not quite looking like this, is it? Not quite, because I need 1x over there, which means I need to factor out a 4. And now it looks similar to what I have over there. So y'all going to have to review completing the square. And it may be a good thing to do that this weekend, because when we come back Tuesday to class and talk about ellipses, we're going to be doing some completing the square again. So you may want to review completing the square this weekend. So we said that we have a what? Horizontal axis. Which means we're dealing with something of that form. What's our vertex? It's HK. What's H? H goes along with the X. K goes along with the Y, but this is plus 1, so that becomes what? Negative 1. That's my vertex. And this coefficient out here, we said equal to what? 4p. Y'all remember? From the original? Whatever this coefficient we have in front of x, we said that equal to 4p. Which means p is what? 1, which is greater than 0. So we're dealing with what? A parabola turned to the right. Because the y is squared. Yeah, they're swapped there. So, I found my vertex. I need to find my directrix. Directrix we said was x equals h minus p. So this is hk is 8 minus 1, which is 7. And my focus is the point what? H plus P, comma K. So what's H plus P? H plus P is 9. And K is negative 1. So what does my graph look like? My directrix is the line y equals 7. Excuse me. X equals 7.
The 9 and negative 1.
9, negative 1. My directrix is x equals 7. My vertex is 8, negative 1, which is about here. Okay? And my focus is what? 9, negative 1. So my parabola looks something like that. It's a lot of stuff to remember.
Why don't we put that dotted line?
That's a directrix. This means that what? From here to here, this is our P. The directrix. Well, your parabola will not cross your directrix. It's going to be on the other side. And what that means is that if you've gotten the orientation wrong, like you think it's open to the left, well, if I open this to the left without this information, I'm going to cross the directrix, and it's not going to cross it. Huh? Could be. He's right. Built-in safety. Because even when this is our directrix, it's not going to cross it. It's not going to cross it. It's going to be on what? The other side of it. It's going to point the other way, away from the directrix.
Are we going to have to be able to create parabolas and have to draw?
I don't know yet. We're starting something new. I have no idea what I'm putting on the test yet. Oh, wait till you get to your list, because I'm not good at drawing either. Okay? All right, y'all. Let's look at something else. And we're going to leave this up here. We're going to erase the first two examples we did and leave the last one for now. Okay, the next three examples we will, they want us to find the standard form with its vertex at the origin. So they're telling us in these next three examples that the vertex is the origin. Okay? Find the standard form with the vertexes at the origin. And they give us in the first example the focus being the point 2, 0. And that's all they give us. They give us the focus being the point 2, 0. But the directions told us that the vertex was what? Was the origin. That's in the direction. So vertex is 0, 0. Focus is 2, 0. So if I think about this, and I can just do a little sketch, 0, 0, and I think about 2, 0. If my focus and my vertex are on that same line, then what does that mean? That this axis is going to be what? Horizontal or vertical? It's going to be horizontal. Because we know that this thing is going to turn out this way because my focus will be inside of my parabola. Okay? So knowing my focus and my vertex, this means horizontal axis. Okay? It means horizontal axis. Now, what does the focus represent? And here it doesn't matter if P is greater than 0 or less than 0 because we have to find P. We have to find P. So the focus in this horizontal axis thing is H plus P, comma K. And I'm given that it's the point what? 2, 0, right? Which means P has to be what? 2. I guess I should put this here. This implies that P is 2 because H is 0. This is H, K. So P is 2. So I know P. I can find this out. Notice the vertex is the origin. We're going to be dealing with these equations now. Vertex being the origin. Horizontal axis means what is squared? Y. So y squared equals 4 times px, or y squared equals 8x. y squared equals 8x. So they're simplifying this a little bit by telling us that what? The vertex is the origin. Everybody have this portion here before we erase?
So then the answer we would do if we did that problem would be the y squared equals 8x.
The answer's in the box there. Because all they want is the standard form. They didn't say graph it or none of that. They just want the standard form. Next example with the same directions, they give us that the directrix is the line y equals 3, and that's what they give us. Okay? Along again with the vertex being 0, 0, RHK. But look at my directrix. This, when I'm dealing with the horizontal axis, is x equals something. When I'm dealing with the vertical axis, is y equals something. So this tells me that my axis is vertical. My axis is vertical. Because the directrix with the horizontal axis is x equals some number, and with the vertical is y equals some number. So vertical axis. So what is our directrix? It's y equals what? K minus P. But what's K here? 0. K is 0. And in order for me to make this negative positive 3, P is going to have to be what? Negative 3, right? Because y equals 3 is my directrix. If K is 0, then I have to have those double negatives. So this tells me that P is negative 3. Which means I'm dealing vertically, so I deal with what? X squared equals 4py, or x squared equals negative 12y. Okay? So all this stuff, everything we put up here, with this vertical axis, horizontal axis, it plays a part. Plays a major part. Next example. They give us that we're dealing with a vertical axis, and they give us that that this parabola is passing through the point -3, -3. That's what they give us. Along with still the what? Vertex being 0, 0, which is our HK. Okay? Now, vertical axis means what? Means x squared equals 4py, right? The x is squared. Which means I need to find p. How can I find p? Well, knowing that this parabola passes through this point, this is some xy on that parabola, isn't it? That point, so I can put my x and y here and find what? P. Right? It's a solution point. It's on the parabola. It represents an xy. So, let me replace my x with -3 and my y with -3. So what I have is 9, both negative. 9 equals -12p. So P is -3/4, which means I have x squared is what? 4 times -3/4 y, or x squared is -3 y. X squared is negative 3y. Okay? So, those three examples, I was dealing with what? The vertex at the origin. My last example for today just tells us to write the standard form. It doesn't tell us anything about the vertex. Probably won't be at the origin, but we want to find the standard form. Okay? The first example, they give us that the vertex is the point negative 1, 2. And the focus is the point negative 1, 0. And that's all that they give us. But the vertex we know is H, comma, K. We know that. So from this, I should be able to tell whether I'm dealing with vertical or horizontal axis. Right? If I think about it, all these examples, well, I'll erase my examples, but my focus and my vertex lie on the same line, and they lie on what? The directrix. So being that my x coordinates are the same, what does that mean? My x coordinate here is negative 1, here is negative 1. What does that mean? That the axis is vertical. Let's think about this. If I draw this, if I just happen to do a little sketch, negative 1, 2, and negative 1, 0, then what? I know I'm going to be turned this way. Okay? Okay? I'm going to be turned that way. Did I do that right? Negative 1. I did, didn't I? I did it backwards. Gosh. Negative 1, 2. And negative 1, 0. And it's down. It's vertical. Vertical axis. So that tells me that whatever I do, my P should be negative. You know, my P should be negative. What do I know about that focus? What do I know about the focus? The focus for the vertical is the point H, comma, K plus P. Okay? And I know that what? H is negative 1, and I know that K is what? 2. So knowing that this is 0, what is P going to be? Negative 2. Does that make sense? Let's write this a little clearer. H is negative 1 from my focus. My K is 2. And I have to add this to get what? 0. So if I add a negative 2, this means P is negative 2. Okay? So I have my H, my K, and my P, which means vertical means what is going to be squared? X. So it's going to be X minus H squared equals 4 times P times Y minus K. So this is X plus 1 squared equals negative 8 times Y minus 2. Okay? And that's if we're given the vertex and the focus. Next one. Suppose we're given the vertex being negative 2, 1, which is our HK, and the directrix is the line x equals 1. So, directrix x equals something, which means what for us? Horizontal axis. Okay? The directrix is what? X equals H minus P. Okay? Well, because the directrix is X equals something. So, what is H minus P? Well, if I know that this directrix is 1, I know that my what? H is negative 2, then I should be able to find P. Should I not? So what is P? 3 equals negative P, so P is what? Negative 3. So I have my vertex and my P. I can find the standard form. I'm in this situation where my what is squared? Y. So Y minus K squared equals 4 times P times X minus my H. So Y minus 1 squared equals negative 12 times X plus 2. Okay. One more. Same direction. Suppose they give us that the focus is the point 0, 0, and the directrix is Y equals 8. So, knowing that the directrix is Y equals 8, vertical or horizontal? Vertical. Now, the focus is what when we deal with vertical? It is H, comma, K plus P. Okay? The directrix is what? Y equals K minus P, which I know is 8. Okay? This is also the point what? 0, 0. So, from here I can tell off the bat that H is going to be what? 0. Right? I need to find K and I need to find P. But if I look, H is 0, K plus P is 0 too, right? Right? And K minus P is what? 8. So can I not solve that little system? Can I not solve that system of linear equations? Because that's what it is, isn't it? To find K and P? I can. This is already set up so that when I add these equations together, I get 2K equals 8, or K equals what? 4. And now that I know that K equals 4, then what is P? Right. So if K equals 4, then 4 plus P equals 0 means P is negative 4. So I have my H, I have my K, and I have my P. And I'm dealing with the vertical axis, so what does this mean? The X is squared. X minus H squared equals 4 times P times Y minus K. So this is really X squared equals negative 16 times y minus 4. Okay? X squared equals negative 16 times y minus 4. Because solving this system of equations, we add together. K plus K is 2K, P minus P is 0, 0 plus 8 is 8. And we can solve that. Any other questions about this lecture?
K plus P equals 0. K plus P equals 0. How is K minus P equal 8?
Because of the directrix. This is the equation for the directrix, but it tells us that it's equal to 8.
Oh.
So that's given, pretty much.
How do you come up with K plus P equals 0? Is that given at the top?
Because, yes, the focus is 0, 0, and that's the equation for the focus in the vertical situation. All right, y'all. This will end our first little topic in this unit on parabolas. Next time we'll talk about ellipses.